Hello, and welcome to the update statement and the delete statement. In this video, we will learn about altering and deleting data in a relational database table. At the end of this lesson, you will be able to identify the syntax of the update statement and delete statement, and explain the importance of the where clause in these statements. After a table is created and populated with data, the data in a table can be altered with the update statement. The update statement is one of the data manipulation language, or DML statements. DML statements are used to read and modify data. Based on the author entity example, we created the table using the entity name author and the entity attributes as the columns of the table. Rows were added to the author table to populate the table. Sometime later, you want to alter the data in the table. To alter or modify the data in the author table, we use the update statement. The syntax of the update statement looks like this: update table name set column name equal to value where condition. In this statement, table name identifies the table. The column name identifies the column value to be changed, as specified in the where condition. Let's look at an example. In this example, you want to update the first name and last name of the author with author underscore IDA2 from Rav Ahuja to Lakshmi Kata. In this example, to see the update statement in action, we start by selecting all rows from the author table to see the values. To change the first name and last name to Lakshmi Kata, where the author ID is equal to A2, enter the update statement as follows: update author set last name equal to Kata, first name equal to Lakshmi, where author ID is equal to A2. Now to see the result of the update, select all rows again from the author table, and you will see that in row 2 the name changed from Rav Ahuja to Lakshmi Kata. Note that if you do not specify the where clause, all the rows in the table will be updated. In this example, without specifying the where clause, all rows in the table would have changed the first and last names to Lakshmi Kata. Sometime later, there might be a need to remove one or more rows from a table. In this example, without specifying the where clause, all rows in the table would have changed the first and last names to Lakshmi Kata. Sometime later, there might be a need to remove one or more rows from a table. The rows are removed with the delete statement. The delete statement is one of the data manipulation language statements used to read and modify data. The syntax of the delete statement looks like this: delete from table name, where condition. The rows to be removed are specified in the where condition. Based on the author entity example, we want to delete the rows for author ID A2 and A3. Let's look at an example. Delete from author where author ID in A2, A3. Note that if you do not specify the where clause, all the rows in the table will be removed. Now you can identify the syntax of the update statement and delete statement, and explain the importance of the where clause in these statements. Thanks for watching this video.
SQL cheat sheet. Basics. Command syntax description example select COLUMN1, COLUM.
Hello and welcome to Database Concepts. In this video, we will learn about different types of models, how we use models to map data to tables, and define relationships between tables. At the end of this lesson, you will be able to explain the advantage of the relational model, explain how the entity name and attributes map to a relational database table, describe the difference between an entity and an attribute, identify some commonly used data types, and describe the function of primary keys. The relational model is the most used data model for databases because this model allows for data independence. Data is stored in a simple data structure, tables. This provides logical data independence, physical data independence, and physical storage independence. An entity relationship data model, or ER data model, is an alternative to a relational data model. Using a simplified library database as an example, this figure shows an entity relationship diagram, or ERD, that represents entities, called tables, and their relationships. In the library example, we have books. A book can be written by one or many authors. The library can have one or many copies of a book. Each copy can be borrowed by only one borrower at a time. An entity relationship model proposes thinking of a database as a collection of entities. Rather than being used as a model on its own, the ER model is used as a tool to design relational databases. In the ER model, entities are objects that exist independently of any other entities in the database. The building blocks of an ER diagram are entities and attributes. An entity can be a noun, person, place, or thing. In an ER diagram, an entity is drawn as a rectangle. Entities have attributes, which are the data elements that characterize the entity. Attributes tell us more about the entity. In an ER diagram, attributes are drawn as ovals. Using a simplified library as an example, the book is an example of an entity. Attributes are certain properties or characteristics of an entity and tell us more about the entity. The entity book has attributes such as book title, the edition of the book, the year the book was written, etc. Attributes are connected to exactly one entity. The entity book becomes a table in the database, and the attributes become the columns in a table. A table is a combination of rows and columns. While mapping, the entity becomes the table. Having said that, the table has not yet taken the form of rows and columns. The attributes get translated into columns in a table, providing the actual table form of rows and columns. Later, we add some data values to each of the columns, which completes the table form. Each attribute stores data values of different formats: characters, numbers, dates, currency, and many more besides. In the book table example, the title is made up of characters. As book titles vary in length, we can set the variable character data type for the title column, varchar. For character columns that do not vary in length, we use character or char. The edition and year columns would be numeric. The ISBN column would be char because it contains dashes as well as numbers, and so on. Using the book entity mapping as an example, we can create the tables for the remainder of our simplified library example using entity names like author, author list, borrower, loan, and copy. The entity attributes will be the columns of the tables. Each table is assigned a primary key. The primary key of a relational table uniquely identifies each tuple or row in a table, preventing duplication of data and providing a way of defining relationships between tables. Tables can also contain foreign keys, which are primary keys defined in other tables, creating a link between the tables. Now you know that the key advantage of the relational model is logical and physical data independence and storage independence. Entities are independent objects which can have multiple characteristics called attributes. When mapping to a relational database, entities are represented as tables and attributes mapped to columns. Common data types include characters such as char and varchar, numbers such as integer and decimal, and timestamps including date and time. A primary key uniquely identifies a specific row in a table and prevents duplication of data. Hello and welcome. This video will cover the key concepts around databases in the cloud. In order to learn SQL, you first need to have a database available to practice your SQL queries. An easy way to do so is to create an instance of a database in the cloud and use it to execute your SQL queries. After completing this lesson, you will be able to understand basic concepts related to cloud databases, list a few cloud databases, describe database service instances, as well as demonstrate how to create a service instance on an IBM DB2 on cloud. A cloud database is a database service built and accessed through a cloud platform. It serves many of the same functions as traditional databases with the added flexibility of cloud computing. Some advantages of using cloud databases include ease of use. Users can access cloud databases from virtually anywhere using a vendor's API or web interface, or your own applications, whether on cloud or remote. Scalability. Cloud databases can expand and shrink their storage and compute capacities during runtime to accommodate changing needs and usage demands, so organizations only pay for what they actually use. Disaster recovery. In the event of a natural disaster or equipment failure or power outage, data is kept secure through backups on remote servers on cloud in geographically distributed regions. A few examples of relational databases on cloud include IBM DB2 on cloud, databases for PostgreSQL on IBM Cloud, Oracle Database Cloud Service, Microsoft Azure SQL Database, and Amazon Relational Database Services. These cloud databases can run in the cloud, either as a virtual machine which you can manage, or delivered as a managed service depending on the vendor. The database services can either be single or multi-tenant depending on the service plan. To run a database in cloud, you must first provision an instance of the database service on the cloud platform of your choice. An instance of a database as a service, or DBaaS, provides users with access to database resources in cloud without the need for setting up of the underlying hardware, installing the database software, and administering the database. The database service instance will hold your data in related tables. Once your data is loaded into the database instance, you can connect to the database instance using a web interface or APIs in your applications. Once connected, your application can send SQL queries across to the database instance. The database instance then resolves the SQL statements into operations against the data and objects in the database. Any data retrieved is returned to the application as a result set. Now let's see how a database instance is created for DB2 on cloud. IBM DB2 on cloud is a SQL database provisioned for you in the cloud. You can use DB2 on cloud just as you would use any database software, but without the overhead and expense of hardware, setup, or software installation and maintenance. Now let's see how we can set up a service instance of DB2. Navigate to IBM Cloud Catalog and select the DB2 service. Note there are several variations of the DB2 service, including DB2 Hosted and DB2 Warehouse. For our purposes, we will choose the DB2 service, which comes with a free Lite plan. Select the Lite plan. If need to, change the defaults. You can type a service instance name, choose the region to deploy to, as well as an org and space for the service. Then click Create. You can view the IBM DB2 service that you created by selecting Services from your IBM Cloud dashboard. From this dashboard, you can manage your database instance. For example, you can click on the Open Console button to launch the web console for your database instance. The web console allows you to create tables, load data, explore data in your tables, and issue SQL queries. In order to access your database instance from your applications, you will need the service credentials. For the first time around, you'll need to create a set of new credentials. You can also choose to create multiple sets of credentials for different applications and users. Once a set of service credentials is created, you can view it as a JSON snippet. The credentials include the necessary details to establish a connection to the database and includes the following: a database name and port number, a host name, which is the name of the server on the cloud on which your database instance resides, a username, which is the user ID you'll use to connect along with the password. Note that your username is also the schema name in which your tables will be created by default. Now that you know how to create credentials for different applications and users. Once a set of service credentials is created, you can view it as a JSON snippet. The credentials include the necessary details to establish a connection to the database and includes the following: a database name and port number, a host name, which is the name of the server on the cloud on which your database instance resides, a username, which is the user ID you'll use to connect along with a password. Note that your username is also the schema name in which your tables will be created by default. Now that you know how to create a database instance on cloud, the next step is to actually go and create one. Thank you for watching this video. And select the DB2 service, IBM DB2 on cloud. On cloud. DB2 on Cloud is a SQL database provisioned for you in the cloud. You can use DB2 on Cloud just as you would use and select for our purposes the default is from your IBM Cloud to create tables in your database instance, as well as an org and space for the service. Then click Create. You can view the IBM DB2 service that you created by selecting Services from your IBM Cloud dashboard. From this dashboard, you can manage your database instance. For example, You can click on the Open Console button to launch the web console for your database instance. The web console allows you to create tables, load data, explore data in your create a set of new credentials. You can also SQL queries. In order to access your database instance from your applications, you will need the service credentials. For the first time around, you'll need to create a set of new credentials. Credentials include the necessary details to establish. Note that your username is also the schema name. Welcome to Types of SQL Statements. At the end of this video, you will be able to distinguish between data definition language statements and data manipulation language statements. SQL statements are used for interacting with entities, that is, tables, attributes, that is, columns, and their tuples, or rows with data values, in relational databases. Welcome to Types of SQL Statements. At the end of this video, you will be able to distinguish between data definition language statements and data manipulation language statements. SQL statements are used for interacting with entities, that is, tables, attributes, that is, columns, and their tuples, or rows with data values, in relational databases. SQL statements fall into two different categories: data definition language statements and data manipulation language statements. Data definition language, or DDL statements, are used to define, change, or drop database objects such as tables. Common DDL statement types include create, alter, truncate, and drop. Create, which is used for creating tables and defining its columns. Alter is used for altering tables, including adding and dropping columns and modifying their data types. Truncate is used for deleting data in a table, but not the table itself. Drop is used for deleting tables. Data manipulation language, or DML statements, are used to read and modify data in tables. These are also sometimes referred to as CRUD operations, that is, create, read, update, and delete rows in a table. Common DML statement types include insert, select, update, and delete. Insert is used for inserting a row or several rows of data into a table. Select reads or selects row or rows from a table. Update edits row or rows in a table, and delete removes a row or rows of data from a table. Now you know that DDL, or data definition language statements, are used. Welcome to Types of SQL Statements. At the end of this video, you will be able to distinguish between data definition language statements and data manipulation language. Language statements. SQL statements are used for interacting with entities, that is, tables, attributes, that is, columns, and their tuples, or rows with data values, in relational databases. SQL statements fall into two different categories: data definition language statements and data manipulation language statements. Data definition language, or DDL statements, are used to define, change, or drop database objects such as tables. Common DDL statement types include create, alter, truncate, and drop. Create, which is used for creating tables and defining its columns. Alter is used for altering tables, including adding and dropping columns and modifying their data types. Truncate is used for deleting data in a table, but not the table itself. Drop is used for deleting tables. Data manipulation language, or DML statements, are used to read and modify data in tables. These are also sometimes referred to as CRUD operations, that is, create, read, update, and delete rows in a table. Common DML statement types include insert, select, update, and delete. Insert is used for inserting a row or several rows of data into a table. Select reads or selects row. DL, or data definition language statements, are used for defining or changing objects in a database, such as tables, and DML, or data manipulation, are used for manipulating or working with data in tables. Thanks for watching this video. Selects row or rows from a table. Update edits row or rows in a table, and delete removes a row or rows of data from a table. Now you know that DDL, or data definition, Welcome to Create Table Statement. At the end of this video, you will be able to explain how the entity name and attributes are used to create a relational database table. Now let's look at the most common DDL statement, create. The syntax of the create table is shown here. You start with create table, followed by the name of the table you want to create. Then enclose the rest of the statement inside a pair of parentheses or round brackets. Each row inside the parentheses specifies the name of a column, followed by its data type and possibly some additional optional values that we will see later. Each attribute or column definition is separated by a comma. For example, if we want to create a table for provinces in Canada, you would specify create table provinces, open parentheses, ID car 2, primary key, not null, comma, name varchar 24, close parentheses. In this example, the data types used are car, which is a character string of a fixed length, in this case 2, and varchar, which is a character string of a variable length. In this case, the variable character field can be up to 24 characters long. Issuing this statement would create a table in the database with two columns. The first column, ID, for storing the abbreviated two-letter province shortcodes, such as AB, BC, etc. And the second column, called name, for storing the full name of the province, such as Alberta, British Columbia, etc. Now let's look at a more elaborate example based on the library database. This database includes several entities, such as author, book, borrower, etc. Let's start by creating the table for the author entity. The name of the table will be author, and its attributes, such as author_ID, first name, last name, etc., will be the columns of the table. In this table, we will also assign the author_ID attribute as the primary key, so that no duplicate values can exist. Recall, the primary key of a relational table uniquely identifies each tuple or row in a table. To create the author table, issue the following command. Create table author, open parentheses, author_ID, car2, primary key not null, comma, last name varchar 15, not null, comma, first name varchar 15, not null, comma, email varchar 40, comma, city varchar 15, comma, country car 2, close parentheses. Note that the author_ID is the primary key. This constraint prevents duplicate values in the table. Also note that the last name and first name have the constraint not null. This ensures that these fields cannot contain a null value, since an author must have a name. Now you know that create is a DDL statement for creating entities or tables in a database, and the create table statement includes definition of attributes of columns in the table, including names of columns, data types of columns, and other optional values if required, such as the primary key constraint. Thanks for watching this. Hello and welcome to Alter, Drop, and Truncate tables. After watching this video, you will be able to describe the alter table, drop table, and truncate statements, explain the syntax, and use the statements in queries. You use the alter table statement to add or remove columns from a table, to modify the data type of columns, to add or remove keys, and to add or remove constraints. The syntax of the alter table statement is shown here. You start with alter table, followed by the name of the table that you want to alter. Differently to the create table statement, though, you do not use parentheses to enclose the parameters for the alter table statement. Each row in the alter table statement specifies one change that you want to make to the table. For example, to add a telephone number column to the author table in the library database to store the author's telephone number, use the following statement. Alter table author, add column, telephone underscore number, big int, semicolon. In this example, the data type for the column is big int, which can hold a number up to 19 digits long. You can also use the alter table statement to modify the data type of a column. To do this, use the alter column clause specifying the new data type for the column. For example, using a numeric data type for telephone number means that you cannot include parentheses, plus signs, or dashes as part of the number. You can change the column to use the car data type to overcome this. This code shows how to alter the author table. Alter table author, alter column telephone underscore number, set data type car, open parentheses 20, close parentheses, semicolon. Altering the data type of a column containing existing data can cause problems, though, if the existing data is not compatible with the new data type. For example, changing a column from the car data type to a numeric data type will not work if the column already contains non-numeric data. If you try to do this, you will see an error message in the notification log and the statement will not run. If your spec changes and you no longer need this extra column, you can again use the alter table statement, this time with the drop column clause to remove the column as shown. Alter table author drop column telephone underscore number semicolon. Similar to using drop column to delete a column from a table, you use the drop table statement to delete a table from a database. If you delete a table that contains data, by default the data will be deleted alongside the table. The syntax for the drop table statement is drop table, table underscore name, semicolon. So you use this statement, drop table author, semicolon, to remove the table from the database. Sometimes you might want to just delete the data in a table rather than deleting the table itself. While you can use the delete statement without a where clause to do this, it is generally quicker and more efficient to truncate the table instead. You use the truncate table statement to delete all of the rows in a table. The syntax of this statement is truncate table, table underscore name, immediate, semicolon. The immediate specifies to process the statement immediately and that it cannot be undone. So to truncate the author table, you use this statement, truncate table, author immediate, semicolon. In this video, you learned that the alter table statement changes the structure of an existing table, for example, to add, modify, or drop columns. Parentheses, semicolon, plus signs, or by the data type of a column.